Welcome to The Explainer. Today, we're diving into a groundbreaking scientific paper that could change how we think about sleep forever.
I know, it sounds like something straight out of science fiction, right? But what's wild is that new research is suggesting the answer is a pretty definitive yes.
So the secret here, it's not just about, how long you sleep. It's not even about whether you feel rested. The real clues are hidden in this incredibly complex story our bodies are telling, second by second while we're completely out.
Okay, so how on earth do scientists actually read this hidden story? Well, they have to learn to listen. They have to tune in to this really complex, really subtle language of sleep.
And the gold standard for listening in is something called a polysomnography, or a PSG. Now, don't think of this like your Fitbit. It's way more intense. It's like a full-body diagnostic, capturing this whole symphony of data from your body all night long.
First up, it all starts with your brain. A PSG captures the electrical chatter of your brain waves with an EEG. And these signals, they're the key. They tell us exactly what stage of sleep you're in, whether you're lightly dozing, in deep rest, or dreaming. Then it adds the steady rhythm of your heart. An ECG is tracking your heart's activity all night long, and it's looking for these tiny, subtle variations, dips in the pattern that might, just might, signal that there's trouble brewing years down the road.
And on top of all that, it tracks the mechanics of every single breath you take. So you can see the problem, right? You end up with this massive, multi-layered data set that for decades has been just incredibly difficult, almost impossible to analyze. Well, until now.
And this is where things get really interesting. This is the breakthrough. Enter a new AI model, one called SleepFM. Think of it as the universal translator, designed specifically to crack the code of sleep.
Okay, but SleepFM isn't just any AI. It's a special type called a foundation model. Now, what does that mean? Well, the big difference is that older AIs, they were trained for one very specific job, right? Like, find this one problem. But a foundation model, it's different. It learns the fundamental patterns, the basic grammar of all the data first. It learns the language before it tries to translate.
And to build that foundation, wow, you need a staggering amount of data. Get this. The researchers fed SleepFM over 585,000 hours of sleep recordings. That's from more than 65,000 different people. I mean, to put that into perspective for you, that is anywhere from 5 to 25 times more data than any previous sleep model has ever been trained on. It's a whole different league.
All right, so the big question is, after this AI learned the entire language of sleep on this massive scale, what could it actually tell us about a person's future health? Well, let me tell you, the results are absolutely stunning.
From just a single night's sleep data, just one night, SleepFM was able to accurately predict the future onset of over 130 different diseases and conditions. And we're talking years, sometimes, before a doctor could ever make a clinical diagnosis. It's incredible.
And its predictions for some of the things we fear most, they were shockingly accurate. This chart shows a metric called the C-index. Just think of it like a grade. A 1.0 is a perfect score, a perfect prediction. A 0.5 is basically a coin flip, a random guess. And look at these numbers. SleepFM hit 0.85 for dementia, 0.84 for predicting death from any cause, and 0.80 for heart failure. Those are just remarkable scores.
Now, you might be thinking, is this just some random thing the AI found? Nope, not at all. As the paper points out, scientists have known for a long time that sleep disturbances are often one of the very first warning signs for a whole bunch of diseases. The AI isn't inventing this link, it's just seeing those early signs with a clarity that we humans never ever could before.
So let's really nail this down, because the crucial point here is understanding just how massive of a leap this is. How much better is this than what we can do right now?
Well, the best way to figure that out is to put it to the test. Let's compare SleepFM's predictions to a baseline model. This baseline just uses the standard stuff doctors already have. Your age, sex, BMI, things that we already know are pretty strong predictors for a lot of diseases. Okay, so this table lines them up side by side. It uses a metric called AUROC. It's pretty similar to that C-index we saw before. Higher is better, 1.0 is perfect. And it's not even close. You can see SleepFM, there in the right column, just consistently outperforms the baseline that only uses demographics. And I mean, look at that jump for neurological conditions. And for mental disorders. This is the proof. It shows that our sleep data contains vital, predictive information that goes way, way beyond what you'd see on a standard patient chart.
And this, right here,
really shows the power of that foundation model approach we talked about. SleepFM is so good, so data efficient, that the researchers found it could often beat older models even when it was trained on just a fraction of the data. Because it's learned the fundamental language so well, it doesn't just find the right answer, it finds it way more effectively.
So, this all brings us to the biggest question, right? The so what? What could this new technology actually mean for the future of medicine and, for all of us?
Well, the implications are just huge. I mean, think about it. This could be a totally non-invasive early warning system. It could give doctors a heads up, a chance to step in, and maybe change a person's entire health trajectory years before they would have otherwise. It could be a real game changer, shifting medicine from just reacting to sickness to actually proactively preserving wellness. And this isn't just some theory that only works in a lab. It's already proven itself in the real world. The model has demonstrated that it's robust, it's generalizable, it kept its high accuracy even when they tested it on sleep data from a completely different hospital system that it had never, ever been trained on. That's a huge deal. Which leaves us with one final, fascinating question to consider. Thanks for joining this explainer.